on to you. This went up last week, I think last Wednesday. It shows you what topics there are for quiz 2. This went up this morning. So there's a link in this announcement that shows you a little sample quiz. So I'm just going to look at the sample quiz now. So you'll see that there's one question where I ask you to fill in some methods and constructors, right? So fill in a constructor for this class. It tells you what the class does up here, right? So there's a little description of a class. I give you the name of the class, the fields that are in the class, and then you fill in a constructor, a method, and a second method. Right? This particular sample isn't a great one for the quiz because it requires you to use something that we just talked about. But it shows you the structure of the quiz. The second one is you get a description of a problem, small problem, not a big one. And it asks you to implement a class. And now you have to come up with the constructor, the fields, the constructors, the methods to complete the class. Right? So you see down here, this one's asking you for 1, 2, 3, 4, 5, 6. That's asking you for more than more than it asks for on the quiz. There's 7 things there it asks for. The quiz doesn't ask for 7. I think in total on the quiz you have to fill in 8 constructors or methods, right? And that's it. So you should roughly time yourself to at most 5 minutes per method / constructor, and you should be fine. I don't know if the difficulty is the same in the 2 quizzes, in the sample quiz and the actual quiz. It's really hard for me to gauge difficulty in this course. I think they're roughly comparable, sort of. The actual quiz might be a little bit harder in the first question. Well, one method in the first question, but I'll adjust the marking to compensate for that. All right, any questions about the quiz? There's no answer booklet this time. You just get the printed quiz, and then you fill in the answers in the quiz booklet itself. The problem with the quiz booklets is that it makes it a lot heavier to lug those quizzes around for me. It basically triples the amount of weight that I have to lug around. So I decided I'd be a little bit lazy and just give you question booklets this time. All right. Any questions? You also have an assignment that came up last week sometime. Assignment's relatively short. You have to fill in some, but you have to include Javadoc in this assignment. So you do have to complete the Javadoc. You'll find that when you do the Javadoc, it is slightly tedious. It's not hard, but it's slightly tedious, which is why I only ever ask you to do it once. Okay, so this is the only time I'll ask you to fill in Javadoc on an assignment. All right. We were talking about aggregation and composition in the last class. We were talking about the relationship between classes. And we came across these 2 terms, aggregation and composition. Right? So aggregation and composition are stronger forms of association. Right? So remember what association means, right? If there's an association between a class X and Y, right, then inside the class X there's a field of type Y. Right? So class X has an object of type Y. Right? Aggregation and composition are stronger forms of association. Okay, so both aggregation and composition imply has a, right? So they actually inserted a slide somewhere here. Here, okay. So what aggregation and composition, what they really represent is that they represent a relationship that is a whole and a part relationship, right? So in other words, you're making a class that you decide has to be an aggregate or a composition. So that's the whole. Right? So the class you're making, that's the whole. And that class, or objects of that class, they are made up of other objects. Right? So those are the parts. Right? And so when you have an aggregation or a composition, you have this whole part relationship. The difference between aggregation and composition is that if you have a composition, right, then the parts die when the whole dies. Right? So when your object goes away, all of the individual objects that it's made up of should also go away. Right? So what that means in Java is when you're done with an object, right? When you're done with the whole object, then all of the memory associated with the whole and the parts, all of that gets released back to the Java virtual machine. Right? So everything dies when the whole dies. In aggregation, the parts are allowed to live after the whole object dies. Right? So when you're done with the whole object, it's possible that its individual parts still live on for some reason. Right? And so that's the difference between the 2 in this case. If you Google online for the difference between aggregation, composition, and association, you'll see that a lot of people say there's no difference between association and aggregation. And in practice, so in Java, that's effectively true. There is no real difference. There's no actual difference between association and aggregation. The only difference is the only difference that you can claim between aggregation and association is that aggregation is supposed to be a one-way relationship, right? So the whole is made up of the parts, right? The parts are not made up of the whole, right? Whereas in association, you can have two objects where they both have a link, they both have a reference to one another, right? So that's the only real difference. There's only a very slight difference between association and aggregation. Composition, however, is the strong form of association, right? So composition implies ownership, right? Because in a composition, when the whole dies, everything else goes away, right? So that's the only, so when you're implementing a class, right, if you're using aggregation, everything's very simple. You'll see that in a second. If for some reason you require a composition, things become more complicated. And again, you'll see that shortly. Right? OK, so we're going to implement the what I think is basically a useless class, but it illustrates the point. Right? So here's this little person class that's meant to represent a person, student, whatever, professor, whatever you want, right? Somebody that represents a person, right? Every person has a name, and every person has a birth date. OK, so so the person, the whole, right, is made up of a string and a date, right? So the name and the birth date, these are the parts. Right? Now, when you look at the types on the parts, one is string and one is date. Okay? So the date type in Java, that comes from Java util.date. Date objects are mutable, right? So you can make a date object, and then you can change what date that object represents. Right? Strings are immutable. Right? So once you create a string, you can't change the text in that string. Right? And so whenever you have a mutable field, that's when you have to consider whether or not you want an aggregation or a composition. Right? So because a person is made up of a birth date, this aggregation versus composition becomes relevant. OK, so here's our constructor. Right? So the constructor takes in a name, and it takes in a birth date. Oh, sorry, we have the two fields. OK, so the constructor is straightforward in this case, right? So we say this name equals name, this birth date equals birth date, right? That's the line you need to pay attention to here. That one right there. Right? So when we get the name, we just return this dot name, and when you get the birth date from a person object, you just return this dot birth date. Right? And again, this is a line that's also important. Right? So that one and that one, right? Wherever we're doing something with the birth date, there's a possible issue. OK, now remember what happens when you write this birth date equals birth date, right? The parameter birth date, that's a reference to an object, right? So that's what you get back, right? Because it's a reference type. Right? When you say this birth date equals birth date, you're saying that the field, this dot birth date, right, refers to the same object as that field, as that parameter birth date. Right? So in other words, the person doesn't have their own birth date. Right? They got a reference to a birth date, but they don't own, in this particular case, they don't own the date object that refers to that is the birth date. Right? So there's no, in other words, the person class is not making a new date object to store the birth date. Right? They're just using an existing date object as the birth date. Right? So in that example there, that uses aggregation. So that's basically the way we've been implementing classes so far in the course. Right? The constructor does not make a new copy of the name, and it doesn't make a new copy of the birth date when it's passed. It doesn't make new strings and new date objects for the name and the birth date. Right? So what does that mean? It means the person object is actually sharing the string object and the date object with whoever called the constructor. Right? So whoever called the constructor, whoever wrote new person, blah, 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 right? That person, that user has a reference to the name, and it has a reference to the birth date. Right? The person object also has a reference to the same name and the same birth date. Right? So both the client, or the caller of the constructor, and the person object, they're holding references to the exact same string and the exact same date object. Right? So here's someone who's going to use the person class, right? They have a name, Billy Bob, and they make a date, 1991, March 26. Right? The date class is very strange. Right? So the number 2 in the second place indicates the 3rd month, which is March. The number 26 indicates the 26th day, right? So that's March 26th. Okay, when we make a person object passing in the string and the date object, right? This is a picture of what happens in memory, right? So the caller, or the client that I'm calling them in this slide, right? They have a string S, right? That's Billy Bob. So here's our string object, right? They made a date object here, right? March 26th. So there's the date object, right? The caller has a reference to that string, right? And they have a reference to that date, right? And then they make a person object. So they have a reference to the person object, right? Now, when you go and look inside the person object, right, there's a name, right? There's a field called name, but that field, right, just points to this string here, right? The person object also has a field called birth date, but that field just points to that date object there, right? So you've got the caller of the person constructor, right? And you've got the person object, right? But between the two, there's only one string and one date. Right? So here the person object and the client have a reference to the same string, and the person object and the client have a reference to the same date object. So what happens if either the person or the client modifies the date? Right? So D, set year to 95, right? That changes that object here, right, to 1995. Right? If we change the month to 10, that changes it to November. And if we change the date to 3, that now becomes November 3rd, 1995. Right? So if you now ask the person, when were you born? Right? The person now tells you they were born November 3rd, 1995. Right? They don't tell you their original birth date, right? The birth date with which that object was constructed with, right? It doesn't report back March 26, 1990. It reports back November 3rd, 1995. Right? So in other words, you're able to change the birth date of a person without actually asking the person object. Right? All you do is fiddle with the date, and all of a sudden the person's birth date also changes. Okay, so because the date instance is shared by the client and the person instance, right, the client can modify the date using the person instance. Oh, sorry, the client can modify the date using D, right? That's their reference to the date. And the person instance, P, sees a modified field called birth date, right? Their birth date field now changes to be the new date, right? Similarly, if there's some method inside the person class that changes the birth date, then the client's object that they're calling D also changes, right? So the opposite can also happen, right? If the person modifies this.birth date to refer to some new birth date, if the client uses this.birth date to change its birth date, then whoever created the person object, their object D now also changes. Right? Now, the name, this never happens to the name. Right? So structurally, everything is the same between the string and the date object in this example. Right? But there's something special about string. Right? String is immutable. So there's no way for somebody to change the string object that they're sharing. Right? So in other words, in this example, that string is always Billy Bob. Right? And neither the person nor the caller can change the state of that string. Right? And so you might come across the statement that immutable objects make great building blocks for other objects. Right? So because you never worry about the state of the string changing, right? The person object never has to worry that its name is going to change if somebody else mutates the string. Right? Similarly, whoever made the person object never has to worry about the person object changing their string underneath them. Right? And so if you can create an immutable object, so an object whose state never changes, it becomes easy to write code. Right? because you can just, you don't care about composition anymore, right? Because you can never change the state of the object anyway. Right? So in other words, you can freely share immutable objects without ever worrying about their state. Right? Now, immutable objects, they have a lot of limitations, right? They can never change. So it doesn't make sense, for example, to make an immutable list. Well, it doesn't usually make sense to make an immutable list, right? Because normally you want to add things and take away things from a list, right? But things like strings, well, it might be a good idea to make them immutable. Okay, so the person example there is an example using aggregation. Right? So if you wanted to draw the UML diagram for an aggregation, then on the whole object, you attach these little diamonds. Right? And so on the diamonds, you draw a line to the part. Right? So this says that a person is made up of one string, right? And a person is made up of one date. Right? And it's an open diamond. Right? Open diamond here. So that indicates aggregation in this example. Okay, here's another aggregation example. Don't worry about the equations here. This is the bouncing ball example. So let me just, here, I got a little video here. Right? So there's a little program called bouncing ball somewhere in the source code that I gave you. And it opens up a little window, and it has this little ball that bounces up and down. Right? The equations here, they just describe the equations of motion of this ball. Right? If you haven't taken physics, don't worry about it. It's not a big deal. Right? We don't actually care about the equations. Right? Now, that ball, or projectile, I think I'm calling it, you can get the location of that projectile. Right? So that projectile, right, is, if you use aggregation, then the projectile is made up of one point object. That's its location. Right? And it's made up of one vector object. That's its velocity. Right? So we don't care about the velocity in this example, but we do care about the position. Okay, so this is what it would look like if you actually implemented this class. Right? So here's our class projectile. Right? It's aggregation, right? So projectile has a point2 object, right? Projectile has a vector2 object. So there's a field of type point2, and there's a field of type vector2, right? One for the position, one for the velocity. Okay, so our constructor here, right, makes a new point object and it makes a new vector object. So in other words, it makes a projectile whose position is 0, 0, and its velocity is 0, 0. So it's not moving. Right. There's a getPosition method. Right. GetPosition just returns our field, this position. Right. And getVelocity just returns the field, this dot velocity. Right. So this is, there's nothing new here in this example. Right? If I was to ask you to implement a class, what's a good class that we have that we've done? I can't remember now. If I asked you to implement a class and it had a primitive field and I asked you to return one of the fields, you would just return this dot blah. Right? Well, it's the exact same thing when you have references. Right? If I want the position, I can just return this position, and if I want the velocity, I can just return this dot velocity. I think this is I think these slides have some typos in it. This is this dot POS, and this should be this dot VEL. Yeah, see, I get them mixed up all the time. Okay, if you this one lets the user change the position of the projectile, right? So you pass in a new point, indicating the new position of the projectile, right? And then it returns the previous position of the projectile, right? So the current position is just this dot POS, right? Now change the current position, so this dot POS equals P, and then return the old position. Right, you do the exact same thing for the velocity. Right, and now here's move. So these two equations here, these two lines here, those are just the equations that were shown on the slide a few slides ago. Right? But move, oh, this one's slightly different. That's fine. So move moves the projectile. Right? After some amount of time dt, it moves the projectile to some new point. Okay, so when you implement that thing there, it's pretty easy. Right? Assuming you can implement the equations here, right? But otherwise, nothing here is very complicated, right? The constructor does, right, nothing new, right? We know that when you have a constructor, you have to initialize the fields, right? So in this case, I have to make a new point and a new vector. So we know that, right? We know that to return a field, you can just return this dot the field name, right? If I want to change if I want to change the position of the point, well, I just change the field. Right? If I want to change the velocity, again, I just change the field. So all of this is relatively straightforward. Right? So the fields are just references to objects that are provided by the caller. Right? There are accessor methods, so get position and get velocity. They just return our internal fields. Right? Anything that changes the position or velocity, well, we just change the fields again. Right? So inside that projectile class, right, the fields this.pos and this.vel, right, for the most part, those are just references to some objects that the client also has references to. Right? So in this case, it's not unusual for the client to have a reference to a point representing the position of the particle, of the projectile, sorry. Right? And the projectile, it has a reference to the same object. Right? So in other words, there's two different variables that point to the same object in this example. Right? So whenever you have more than one thing that points to the same object, right, we call those aliases. Right? Different names, same object. Right? Here's a little example of a little main method. Right? So I'm going to make a new point, 1020. Right? I'm going to give it a velocity 1, 2. I'm going to make a projectile. I'm going to set the position and velocity of that projectile to that. Right? I think I'm going to show you the memory diagram next. Right? So I'm going to make a point 2 object and a vector 2 object, and then a projectile object. Right? So there's the point 2 object. Right? There's the vector 2 object, and there's the projectile object. Right? So I have a reference to the point. Right? So the 250, the object address 250 is here. Right? I have a reference to a vector object, so that's that object over here. Right? And I have a reference to a projectile object, and that's that reference right there. Right? That's that object right there, sorry. Now internally, right, that projectile object, right, its position, well, it's just that object there. Right? And its velocity is just that object there. Right? So again, just like in the previous example with the person, right, there's the user and there's the object, right? And both the user and the object have references to the same part objects. So in other words, the projectile object doesn't actually own that vector, and it doesn't own that point. Right? It can't own them because I have a reference to that point and that vector as well. Right? Okay, so if I ask the ball for its position, right, and I save that in a variable called ball.ballPOS, right? Is the position of that ball, right, is that object, is that the same object as that object up here? Right? So remember what equals equals does, right? Equals equals is, are they the same objects, right? It doesn't mean do they have the same state, right? Is that object the same as that object? And the answer is yes, right? Right? So ball POS, well, that's just that value there, right? That reference is the exact same as that reference, right? So they have the same values. So ball POS equals POS is true, right? Now, if in the main method I take that object right there, right, and change the position, right, what happens to this variable right here? Right? So notice that variable right here, I didn't ask for the ball position again. Right? I asked for it once up here. Right? I change the object POS here. Right? Now, does that object also change? Right? And the answer is yes. Right? It also changes because that object, right, is just a reference to this object here. So the state of this variable right here, ball POS, has magically changed, right, when I use a different variable. Right? But none of this should be surprising because ball POS and POS, well, they're actually pointing to the same object. Right? So that thing there really changes. So it doesn't matter now if you use that, or that, or that. Right? They all refer to the same object. Right? So if you change this object using any one of those three variables, right, then it doesn't matter which variable you use to access the object, it's going to see the same changed object. Okay, so if somebody can get a reference to that position or the velocity of the projectile, right? So in other words, if someone can get a reference to that or that, right, then that person can change the position or the velocity of the ball without asking the projectile, right? So in other words, I can make a projectile like right here, right? I can set the position and the velocity of the ball once, right? And then I never move the ball again directly, right? I never say ball dot something, right, to move the ball, right? All I do is I use a different variable to change the position here, and now suddenly the ball also changes position, right? And you might think, well, that's weird, right? That I can change the position of the projectile without asking the object that is the projectile, right? And it's, well, it might seem weird to you, but it's not, there's nothing actually wrong with this. Right? And a lot of Java and Python code actually works this way, right? So this is not a flaw of aggregation, right? It's simply a consequence of the fact that we're using aggregation, right? So we made this design decision that, look, I'm not going to make a new position and a new point and a new vector whenever I make a ball or a projectile, sorry, right? Or whenever I change the position of the projectile, or whenever I do something with the projectile. Right? I'm just going to use existing objects for the position and the velocity. Right? So this is not a flaw. Right? So let me just run this little program here to show you what's going on here. Okay, so in this program here, so I'm going to show you the bouncing ball program. And in the console here, I'm going to print out the number of point 2 objects that have been created in the program. So the way I'm doing this is I change point 2. Right? So in point 2, I stuck in a static field, right? So I stuck in a static field called instances, and I set it to 0, right? Now this field is going to keep count of the number of point 2 objects that I've created, right? So how do you keep count of the number of point 2 objects that are created? Well, you can create an object using a constructor, right? So okay, that's fine. So every time in the constructor, I'm just going to update that static field. I'm just going to increment it by 1. Right? Now remember, it's static, right? So there's only one copy of this field, and it belongs to the class, right? In other words, all the point 2 objects, right, they all share that same variable right there, right? They don't have their own individual copy of instances, right? So whenever I touch instances, right, the one copy changes, right? So whenever inside every constructor, I just increment the value of instances, and this lets me keep count of how many point 2 objects the program creates. Right? So when I run this program, you do, hopefully, where to go? Is it run? It's not running. Sorry, wrong program is running. Okay, there we go. Right? So there's ball bouncing around. If you click over here, you can see that it's just printing out 2 every time. Right? So a total of 2 point objects are created. The ball's going all over the place. Right? And there's still only 2 point objects that have ever been created. Right? Ball's still bouncing around. Still only 2 point objects in this entire program. Right? So that's great. Okay. Suppose you decide, look, this is silly. I don't want the ball to move if somebody fiddles with a variable that they own. Right? So in other words, I want the projectile to own its own point 2 object. Right? So I want the projectile to exclusively own its own point 2 object. So what does that mean? Right? So what that means is, what that means is that you can never hand out a reference to that object right there. Right? So in other words, every projectile object owns its own point 2 object. Right? Exclusively owns its own point 2 object. Right? Never hands out a reference to that point 2 object. Right? Because as soon as I hand out a reference to that object, somebody can change the object, and now suddenly the position of the ball changes. Right? So what does that mean? Right? So that means whenever I accept a reference to a point 2 object, and I want to set the position of the ball to that object, I have to make a new copy of that object. Right? Because this means this dot POS and POS, they both point to the same object. Right? Well, I don't want that. I want this POS to point to my own object. So what does that mean? I have to make my own object every time. Right? So I have to make a copy of the incoming point object and do that. Right? Okay. So what happens when I return the position back to the caller? Well, I can't return a reference to my internal point 2 object. Right? Because now somebody can take that reference, fiddle with the coordinates of the point, and suddenly the ball changes. Right? So what do I have to do? I have to return a copy of that point object. Right? So I have to make a new point object and return a copy of that object. Right? What about set position? Right? So set position, this is the one that changes the position of the ball. Right? So here, right, I can't write this POS equals P. Why not? Because now POS and P refer to the same object. Right? So what do I have to do? Well, I have to make a copy. Right? So I have to make a copy of the incoming point object, set this POS to point to the copy. Okay, now this version of move, okay, that's fine. Right? Okay. Now, what does this mean? Right? So, how does bouncing ball work? Right? So inside the bouncing ball program, there's a method called thisDrawBall, right, which draws the ball somewhere on the screen. Now, how does that work? Well, that gets the position of the ball. Right? So every time I want to draw the ball, I need its position. So I have to ask the ball for its position. Right? Okay, so here's my bouncing ball program. Now remember before when we ran it, we used aggregation, right? There was only ever 2 point 2 objects. Now how many point 2 objects there are, right? Every time I move the ball, right, and I go to draw it again, I have to make a new point 2 object, right? So now this program is running a few seconds, and we've made, well, an increasing number of point 2 objects, right? The only reason we're making the only reason we're getting the position of the ball is to draw it each time, right? After that, I don't care about the position anymore, right? So this program here has to make, well, thousands and thousands and thousands of point 2 objects just to draw the ball, right? Which seems wasteful, right? And it is, but it's the only way that you can guarantee that the ball doesn't move unless you ask the ball to move, right? It's the only way you can guarantee it. So there's a price that you pay if you want the ball to own its own point 2 object, right? Every time someone asks for that point 2 object, you got to make a new copy of that point 2 object, right? So instead of only using 2 points, right, to run a program for a few seconds, right, I now need to make, well, 30 some odd thousand points to run the program for a few seconds, right? Which is a waste of memory and time. Yes?
I just had a question. So, like, when you make the program this way,
Yep.
those copies, like, of point 2, like, don't
Yep.
get deleted after them? Like, or do they just keep on existing as you go ahead?
No. So the copy gets made here, right? Whenever I ask for the position of the ball, right? So that copy gets made, right? We use it here, right? And then we never use it again in the same method, right? So I never use that reference again. So at that point, the Java virtual machine can mark that object as being disposable. And so it can eventually go away. Exactly when it goes away is not within your control. But it will be freed back to the virtual machine. Yeah.
And then the second thing is, like, as it keeps on bouncing,
Yep.
if it ends up at the same, like, X and Y position,
Yeah.
does it get referenced to the same object that existed
No.
before? It's a completely
No. It's a completely new object every time. Yeah. That last question was quite advanced, by the way. We can talk about it later if you want, offline. Okay, so composition, right? So if you want your whole object to actually own its parts, That's when you have to use composition, right? So an object of type X that is composed of an object of type Y means X has a Y, right? And X owns the Y, right? So in other words, in composition, right, the X object or the whole object is supposed to have exclusive access to its part objects, right? And so what does that mean? Well, I just showed you what it means in Eclipse, right? What it means is that the X object can never hand out a reference to its Y object. It also can't share its Y object with anybody else, right? So it can't have that Y object point to some other object that someone else knows about. Right? So what does that mean? That means in your constructors, right, you almost certainly have to make new copies of every Y object. Right? If you have an accessor method that returns a reference, that you want to return a reference to your Y object, you have to return a copy of your Y object. Right? You have to return a reference to a copy of your Y object. If you want to have a method where you can change or set the Y object inside X, then you have to make a copy of the incoming Y object. Right? All of those copies, right, those are all called defensive copies. Right? So back here, right, in the projectile class, right, in my copy constructor, when I make a copy of the, sorry, in this constructor here, right, I have to make a copy of the incoming point. Right? In the accessor method, I have to make a copy of the internal field and then return a reference to the copy. Right? In the mutator method, where I change the position of the ball, I have to make a copy of the incoming point, right, and then set the field to point to the copy. Right? And so these are all, every time so on all of these lines where I'm making this new point 2 object, right, these are all called defensive copies. Oops, sorry, control. Right? And you need these defensive copies in order to make sure that, in the projectile example, no one can change the position of the ball without asking the ball object itself. Okay, so if you have a no argument constructor, then you know that in a no argument constructor you have to make a new Y object. Right? So this Y equals new Y, and away you go. So the no argument constructors, they don't change. Right? But if you have a constructor that takes in a Y object, well, now that changes. Right? So if I take in a Y object and I want to set this dot Y equal to Y, right? I can't do that. What you have to do is you have to make a copy first. Right? So you make a copy of the incoming Y object. Hopefully, right, the class Y has a copy constructor. Right? So this one assumes that that line of code there assumes that Y has a copy constructor. Right? Not every class in Java has a copy constructor. Right? So you can run into the problem where you actually aren't able to make a copy of an object, and now you have other problems. Right? If you've got a copy constructor or some method that returns a copy, everything's great. This is easy to do. Right? So make a copy. If you have to validate or check the state of Y for some reason, right, then you validate the copy. Right? You don't validate the incoming Y. Right? There's a fairly long and convoluted answer for, explanation of why you validate the copy and not the incoming object. Right? But you should validate the copy. Right? Only once you're sure the copy is fine, right, can you go ahead and set this dot Y to point to the copied object. Right? So that copy there, that defensive copy, you'll sometimes see that called a deep copy. Right? Why is that required? Right? Because, well, X is supposed to have exclusive access to its Y object. Right? Don't write that. Right? If you're writing that, then you're probably implementing an aggregation, right, or an association of some kind. Right? It's not a composition anymore. Right? When you write that, right, what ends up happening is the X object shares its field, right, with whoever called the constructor that passed in that Y object. Right? It's the same Y object in this case. Right? When that happens, right, so when you share, so in a composition, if you end up sharing your internal field with somebody else, that's called a privacy leak. Right? Y is supposed to X is supposed to have exclusive access to this dot Y. but it doesn't. Right? Whoever has a reference to that y object also has access to this dot y now. Right? Okay, if you have a copy constructor, then guess what? You have to copy the other object's y object. Right? So here, we've got a copy constructor for x. Right? You can recognize it's a copy constructor because the parameter here has type x. Right? So I have to copy the other object's y object. Right? So new y, other get y, or other dot y. Whoops, what happens if you don't do that? Right? So in other words, what if I just do what we've been doing so far and write this dot y equals other y? Right? Well, you've implemented an aggregation. Right? This dot y and other dot y, they both refer to the same object. Right? So now you've got two x objects that are sharing a single y object. Right? Not a composition anymore. Right? Every x object has its own y object. So don't do that. Right? Once again, that's a privacy leak. We'll just skip over this slide here. Okay, if you have a method that returns, or where you want to return this dot y, don't do it. Right? Never return a reference to an internal field. Always return a copy of that field. Right? So if I want to return the y field, right, you have to return a copy of the y field. Right? What happens if you don't return a copy? I think that's on the next slide. Right? What happens if you don't return a copy? Right? Then whoever called the method gets a hold of a reference to your y object, right? And now you're x no longer owns its own y object, right? Someone else has a reference to that object, right? Once again, privacy leak. Again, we'll just skip over this slide. I already modified this anyway. Okay, and finally, if you have a mutator method, so I have a method that wants to take in a y object and set this dot y to that y object, don't do it. Right? Copy the y object first. Right? Validate the copy. Only once you're sure that the copy is fine can you go ahead and do this dot y equals copy y. Right? What happens if you don't do this? Right? So in other words, what if you just write this dot y equals y? Right? Well, this dot y and that y, right? They now refer to the same object. So you're now sharing your internal field with somebody else. Right? So once again, you've got a privacy leak. Okay, and I've already modified that one in Eclipse. Okay, so you have to make these defensive copies when you're implementing a composition, right? But there's a price that you pay. Right? So the price is the price of the defensive copies is that it takes time and memory to make these copies. And so I showed you that little bouncing ball program, right? The original version where we used aggregation, there's only ever 2.2 objects, right? As soon as you use composition, then the longer the ball moves, the more 0.2 objects are created. Right? Okay, so I think that's a good place to stop. In the next class, I think we're going to look at an example. Yes, so you're going to see why sometimes you require a composition. Right? You can't use aggregation to correctly implement a class. Right? And so in the next lecture, I'll give you an example of where composition is required. You must pay the price of the defensive copies whether you want to or not. Right? Otherwise, the class doesn't work properly. Okay, so we'll show you an example of that in the next lecture, which I guess is going to be Friday, right? Because your quiz is on Wednesday in class.